Today we're going to learn about equation and inequality solution sets. We're familiar with equation solution sets, but we'll learn about what inequalities are. Our learning target for today is to graph solutions to equations and inequalities on a number line. So represent our solutions graphically, and to determine solutions by testing whether a value makes the equation or inequality true. So we're going to use this trial and error method. It should be page 42 if you've been staying diligent with your notebook. So I want to talk about the difference between a one-variable graph and a two-variable graph. So a one-variable graph is when you have an equation with one variable. You use a one-variable graph to represent the solutions. And a one-variable graph is a number line. So when we have equations, we use number lines. And then when you have an equation that has two variables, you would use a two-variable graph, x and y, because there's two variables. It measures two quantities, whereas the number line only measures one quantity. So we've been using a two-variable graph. To solve equations with only one variable. And let's consider for a moment this equation here, x plus 2 equals 4. What we would do is we would get 0 on one side, so we would subtract one side from both the sides. We get something like this, equals 0, because we minus 4 here. We minus 4 here to get the 0. And then what we would do is we would take this expression that equals 0, and we would type it into the expression bar in our graphing calculator, and then from here we're only concerned with, or we've only ever been concerned with, finding where the line crosses the horizontal or the x-axis. And you can see here our solution was 2. But really we've only been concerned with the point that it was crossing at. So we've actually been using a number line because we've been disregarding all of this. We don't care about the y. We never cared about the y. We didn't care about the rest of the line. We were only concerned with this horizontal axis and the point in which it was crossing the horizontal axis, this point right here. So we've been actually using a number line just in a different way. So that's the difference between a one variable and two variable. We're going to use a number line, a one variable representation for all of our solutions today. So before we begin, let's consider what an inequality is, because we know what equations are. Equation, we have, for example, if we had x equals 1, what we're trying to do is we're trying to find the values that satisfy the agreement. So we want the value here for x that satisfies the agreement that is equal to 1. And we know this, that the only value that is equal to 1 is 1 itself. So 1 is the value that makes this a true statement. That's our solution here. With inequalities, we're not trying to find the value that makes it equal, because in the definition of inequality, it has nothing to do with being equal. It has to do with being unequal, right? So the first example here, x is greater than 1. Several values that are greater than 1 would be 3 or 4.5 or 5.8. All of these values here satisfy the agreement. So they're all included in the solution. Values that are not included in the solution, let's see, what values are not greater than 1? Well, negative 1 is not greater than 1, negative 17 is not greater than 1, 0 is not greater than 1. So these are all values that are not included in the solution. So if we wanted to graph the solution on a number line, we would want to highlight all of the numbers that satisfy the inequality. Well, because we're just looking at all numbers that are greater than 1, what we would do is we would go to where 1 is on the number line, and we're looking for all values that are greater than. So all of these values to the right of 1 all the way to positive infinity are values that are part of the solution. What about 1 itself? Do we highlight, or do we draw the line where 1 is? Well, we have to consider, does 1 make the inequality a true statement of inequality, or does it not? So if we have the inequality 1 is greater than 1. Is 1 greater than 1? No, it is not. It is not considered to be a solution because 1 is equal to 1, and it's not saying anything about it being equal. So where 1 is, we cannot put a dot, or we cannot highlight it with a line, so we put an open circle. So where that 1 is, we'll have an open circle. So not 1, but all the values that are greater than 1. Now let's consider the inequality x is greater than or equal to 1. Well, we have the same inequality essentially. The only difference here is 1 is in fact part of our solution. 1 is greater than or equal to 1. It's not greater than 1, but it's equal to 1, so 1 is included in the solution here. So when we graph our solution set, instead of putting a open dot where the 1 is, we're going to put a closed dot because it's included. Closed is included, open is not included, and we're saying all values that are greater than 1. So all these values are values that satisfy the agreement. X is less than 1. So now we're talking about all the values that are less than 1 are values that satisfy the agreement, but not including 1 because it does not have the equal to. So on our number line, we would go to 1, we would leave an open dot because it is not included, and now it's all the values that are less than 1 that are in our solution set. X is less than or equal to 1. So now we have essentially the same inequality. The only difference is equal to. So now 1 is a part of the solution set, so it gets a closed dot. And so that's what's important to note here is the difference between a closed dot and an open dot. If it is included, it means closed. It means included in solution set. If it is open, then that value that has the open dot over it is not included in the solution set. So very important to note the difference between closed and open. So write the solution set for the following equation, type the answer in set notation. So we're not used to seeing it like this because, like I said earlier in the video, we're used to having a 2-coordinate or 2-variable plane in which we graph it and find where the line is intersecting the horizontal axis. But the line is clearly intersecting, or the dot is on 3. So if we're going to type this in set notation, we would say, okay, for x, which values satisfy the agreement? The values that are included in the solution set is just the value 3. This is the only place that has a dot on the number line. So write the solution set for the following inequality. So now we're looking to see, okay, what values are included in the solution set? Well, we know that none of these values are because there's no dot, nor is there a blue line covering it. We start on 1, so that is our value here. So x is something with 1. The blue is highlighting values that are larger than 1. So 2, 3, 4, these are values that are greater than 1, so we know that x is greater than 1. And then on 1 is an open dot, so we're not going to put an equal to, we're just going to leave it as greater than 1. And we can say for x, the values that are included in the solution set are all values that are greater than 1. Write the solution set for the following inequality, type the answer in set notation. So here we have our set notation, x. For all x, which values are part of the solution? Well, these values seem to be covering the values that are less than or smaller than -2 to the left of -2, and there's an arrow, so they keep going on and on and on to negative infinity. So we can say for x, all values that are less than, and on -2 it is a closed dot, so that means -2 itself is part of the solution. It's included, so we can say equal to as well, so x is less than or equal to, and the value that we start on is -2, so this would be the answer here. Closed dot, equal to. So here our solution line is covering, looks like it starts at 0, 0 is included, all values that are greater than 0, except on 3 there's an open dot, so open dot means not included, so all values that are larger than 0, greater than 0, except 3 is not included. So how would we write that? We would write that just like this. So for x, the values in the solution set are values that are greater than 0 or equal to 0 because there's a closed dot on 0. But x does not include, or x cannot be 3. So that's how we represent the not included when it is not the point that the solutions start on. So all values that are greater than 0 except x cannot be 3. In Schoology, there's a special way of writing the not equal to. We would write x is greater than or equal to 0. However, x cannot equal, not equal 3. And we'll talk about more about that in a second. There's another example that kind of covers this Schoology code. So essentially we have a number line with just an open dot on 4. And this is a special inequality. This is saying, even though you don't see the arrows, this is saying x can be all values, all these values, except 4. So all the values except 4. So when you just see an open dot, it's assuming all the other values are part of the solution, and the only value that's not is the value where the open dot is. So in our set notation, we'd say for x, all real numbers, so x can equal all real numbers, except x cannot equal 4. Or you might see it represented as x cannot equal 4. So this is saying x can be anything except 4, which is essentially the same thing up here. All real numbers except x cannot equal 4. So in Schoology, the way that something like this would be coded would be x can be all real numbers, spacing between the words, and then we would say comma, no space, it cannot equal, and we put in parentheses the value or values it cannot equal, in this case 4. So these two things are saying the same exact thing, just the way that you would put it in the computer if you could not get the not equal to sign. Here's our last example. Given the following inequality, determine whether the value provided is included in the solution set. So here's our inequality, here's the value. We've got to figure out, is this a solution? Would this be a part of the values that are on the solution line if we graphed it graphically, or would it not be? So we've got to figure out, does the value make the statement true? Does it satisfy the condition of the statement, or does it make it false? So our first step is to substitute the value in for where the variables are. So we have negative 7 times 8 minus 8 minus 4 times 8 is greater than or equal to 89. And now what we're going to do is we're going to simplify this expression right here, and we're going to see, does it satisfy our agreement? So I'm going to go ahead and use the calculator to do so. So I've punched this in my calculator the way it appears. I'm going to hit enter or equals, and it gives me a negative 32. So this all simplifies to a negative 32. And now what we have is negative 32 is greater than or equal to 89. Is negative 32 greater than or equal to 89? No, it is not. So it gives us a false. It does not satisfy the statement of inequality. So this would be no. It is not a solution. If it satisfied the statement of inequality, it would be yes, it is a solution.